Welcome to section 4.2 Adversarial Examples. In this lesson, we'll explore one of the most fascinating and concerning aspects of AI security. We'll discuss how seemingly tiny, almost invisible changes to input data can trick even the most advanced AI models. And now, here are our learning objectives. By the end, you'll be able to clearly define adversarial examples in simple terms, understand how small changes can cause misclassifications, explore visual attack examples, and review conceptual defense strategies. All right, so what are adversarial examples? Adversarial examples are inputs that have been intentionally modified in subtle ways to fool an AI system. To a human observer, these modifications are almost invisible. The input looks completely normal. However, to the model, these small modifications push the output in the wrong direction, leading to incorrect predictions. Essentially, adversarial examples exploit blind spots or weaknesses in the model's decision boundary, exposing how brittle some AI systems can be when facing carefully engineered attacks rather than natural data. So, visual adversarial attacks are the most intuitive and widely discussed examples. Imagine a stop sign on the road. By adding barely perceptible pixel changes, invisible to a human driver, an attacker could cause an AI model to misclassify it as a speed limit sign. The human still sees a stop sign, but the machine visual system sees something else entirely. These attacks are particularly dangerous in safety critical systems, such as autonomous vehicles or medical imaging, where an incorrect classification could have serious or even life threatening consequences. The reason adversarial examples work lies in how AI models, especially deep neural networks, process data. These models don't see objects the way humans do. They rely on complex statistical patterns across thousands or millions of dimensions. This high dimensional space makes them sensitive to very small changes that shift inputs just enough to fool the model. Humans rely on gestural perceptions. We see the whole object, but models can't be misled by but models can be misled by subtle manipulations at the pixel or feature level that accumulate into major misclassifications. To defend against adversarial examples, researchers have developed several strategies. One is adversarial training, where models are deliberately exposed to adversarial inputs during training, so they learn to be more resilient. Another example is input sanitization, where inputs are pre processed or filtered to remove suspicious modifications before reaching the model. Additional techniques include ensemble methods, using multiple models to reduce single points of failure, and redundancy, where systems cross check results for consistency. While no method is perfect, combining these strategies increase robustness and raises the cost of a successful attack. Alright, so to summarize, adversarial examples are inputs designed to trick AI systems through subtle changes invisible to humans. Visual adversarial attacks, like misclassifying traffic signs, highlight the risks in real world applications. The root cause is the high dimensional nature of AI models, which makes them overly sensitive to small modifications or changes. Defenses such as adversarial training, sanitization, and assemble methods provide partial protection, but building resilient AI will always require layered, and evolving strategies. Thank you for joining this lesson, and we'll continue building on these concepts in the next section. Until then, thank you for joining me.